Hi guys, welcome to one more video. In this one, we'll do merge sorted array. So we're going to skip reading textual part of the problem description because I've spent last 30 minutes trying to draft this problem, and with every draft it became more and more confusing. So I said, let's skip reading the textual part, let's go to the examples and I'll try to explain it over there. So let's look at the examples. So we're given two arrays, nums1 and nums2. They both are sorted arrays, so increasing order numbers, and they both have positive integers. There's one special thing in nums1. Now nums1 has additional space. So apart from the numbers which are sorted, there are zeros which denote additional space. And the space is such that all the elements from nums2 can fit in that additional space. And what do we have to do? We have to merge nums1 and nums2 into nums1 itself so that nums1 is one array with numbers from nums1 and nums2 and both are in sorted. So complete array with sorted numbers and just one array. So let's look at the examples, right? So nums1 is 135 and then additional zeros. And we are given length 3, right? Because there's no way for us to tell like whether nums1 has 3 numbers or 10 numbers because nums1 dot length will give us 8, and then nums2 has 2 4 6 8 10 and the length of 2 is 5, and we need to return nums1 such that all the numbers from nums1 nums2 are there in sorted order. And likewise we have second example. So that's the problem. I hope I was able to explain using the examples. So let's go to the whiteboard, let's try to figure out the algorithm and then come back and run the code.
Okay guys, this is our merge sorted arrays whiteboard. We have our examples nums1 and nums2. I know this whiteboard is a little bit overwhelming, but don't worry about it. We'll go step by step and we'll understand everything. So I think the complex part of this problem is we need to do merging of two array in place. So when I say in place means we have to do it within nums1 itself. If we had to do it in third array, we would just simply take those elements, put in third array, and then we would be done. So that's one challenge. And what we need to look at, or what we need to pay attention, is that we have these empty spaces. That's like we can put anything in that, right? So that's where we'll start looking at, or that's where our algorithm will go. So we'll start putting numbers in this empty spaces, and slowly we'll have our sorted array in nums1. So let's see how we'll do that. So we'll have three variables, I1, I2, and j. I1 is length 1 minus 1 for the array 1, nums1. I2 is length 2 minus 1 for nums2, and j is the total. So length 1 plus length 2 minus 1. So our I1, which is like for this, right? It's 2. I2 is 4 and j is 7. So what we'll do is we'll compare elements at these indexes and we'll decide which is larger, and that goes in nums1, right? So we'll say compare 5 with 10 and put it at index j. So we'll compare 5 and 10. Obviously 10 is greater than 5, so we'll put 10 at j and we'll reduce I2 and we'll reduce j. So now I2 is 3. So we'll again compare 5 with 8 because our I2 is 3. So we'll compare 5, 8. Obviously 8 is greater. So we'll put 8, we'll reduce I2 and we'll reduce j. So next we'll compare 5 with 6. Obviously again 6 is greater. So 6 will go here. I2 will reduce by 1 and j will be reduced by 1. And now we'll compare 5 with 4. Now in this case 5 is bigger, the number in nums1. So what we'll do, at index j we'll put 5 and we'll reduce I1 by 1. So now our array is 1 3 5 0 5 6 8 10. So even though 5 is coming twice, but let's keep going and let's see if it gets sorted. Now what we'll compare? We'll compare 3 and 4. Obviously 4 is greater, so 4 will go here and I2 will be reduced by 1, which is 0. Now we'll compare 2 and 3. Obviously 3 is greater, so 3 will go here and this will become 0. So now look at our array. 1 3 3 4, 5, 6, 8, 10. So we have duplicate 3. But let's keep going. Now 0, 0, right? So we have to compare 1 and 2. Obviously 2 is greater than 1. So 2 will go here. Our nums2 will be done. And since nums1 has the element from nums1, we don't need to do further anything. Just in case if like nums1 was minus and nums2 were left, we'll just have simple trailing while loop. We'll copy nums2 element into nums1 at the remaining indexes. So there you go, guys. It's a simple algorithm. So what we just did, the walkthrough, that whole walkthrough, we can have it in a while loop. While I1 is greater than 0 and I2 is greater than 0, right? While they both are greater than 0, keep doing this. And what we do, compare nums1 and nums2 at their respective indexes. Whichever is greater, copy that element in nums1 at jth index and reduce that index, right? If it's coming from nums1, then reduce I1. If it's coming from nums2, then reduce I2. So if nums1 is greater, copy that value. If nums2 is greater, then copy that value. And likewise, we'll have this array. So there you go, guys. That's the whole approach. Let's just go to the computer, run the code, and make sure we get this output.
Okay guys, this is our final code for merge to array method. Link to C# Java code along with my embarrassing problem description statement would be there in the description below. You guys can refer it, and let's just run it and make sure that we get our output. And so we have this nums1 1 3 5 and then all zeros. Nums2 is 2 4 6 8 10, and we have our merged array. And for our example 2, we have 11 12 and then all zeros, and then we have 2 4 6 8 10 10. So obviously 2 4 6 8 10 would come first, and then 11 12. So that's our merged array in nums1 itself. So there you go, guys. That's about merging two arrays in place and returning that merged array. So if you guys liked this video, if you guys understood the approach, give me a big thumbs up and let me know your feedback and suggestion in comments below. And then as usual, subscribe to the channel for more videos. See you.